Hello all, I hope you can hear me. So this is a classical shake and trim by now. And as usual, we'll give a few more minutes for people to join. So let's give them 3-4 more minutes, and at 5 we'll start.
Hello, everyone. Yes, hi, Jion. You want to say something?
Just a audio check.
It works, it works. Jill, do you want to say something?
So can the chair say something so we are sure that the audio is working?
Yes, I mean, do you hear me? Hello?
Oh, 1, 2, 3.
Yeah, I mean,
I can hear you.
you could hear me all right, because it looks like Eric does not hear us.
Hi, I'm sorry. What time the meeting began?
It starts now, exactly now. So let us just start it now. And welcome. So yeah, this is an official IETF meeting. This is a SCHC interim meeting. And as for any IETF meeting, the traditional IETF not well applies. So if you're aware of any IPR that applies to the discussions that will take place today and that was not disclosed before, please let us know, or please tell the chairs at the end of the meeting. And the anti-harassment procedures and the code of conduct of the IETF also apply to this meeting. And all of the BCPs are listed below. So the agenda is pretty much to continue on the discussion that we have started last week. So it's going to be on the architecture. I pulled the mailing list to see if other subjects were in order. We thought about discussing SCHC over IETF 802.15.4, but we are not really ready for it. So the idea for today is that we continue working on the architecture document. And with this, let's just jump to the continuation of the discussion that we started last time. So just for memory, we are discussing what we need to maintain in the devices for the SCHC session. And so we need to identify when we get a packet over the internet, could be over Ethernet, over IP, over UDP. We need to identify which are the session endpoints, and usually they can be inferred from source and destination, but it could be per layer application endpoints. So if it's not just the source and destination IP address or MAC address that can suffice, then the SCHC header that transports the session information should identify the endpoints. Then between those endpoints, there can be more than one session, so there must be something like a session ID. And that's not totally enough because in a session, one endpoint is the SCHC device and the other one is the SCHC application. So we need to be able to ensure which is which when we receive or send this packet. And then there is all the information that goes with the session that was used to start the session and to maintain it as it's running. So we need something, for instance, like the location where the rules will be located. If it's somewhere on the network where multiple devices can get it, and we need something like a URL. And we need some form of proof that this is the rules that we are talking about. And not only that, but we also need to instantiate that set of rules. For instance, if the rule says source destination IP or device IP, application IP address, then we need to modify, to update the rules, to instantiate them, to apply the right IP addresses. So when instead of having something like $1, you will have the real IP address of the device or the application. And obviously, we need to make sure that that information is well synchronized between the endpoints, because even if the endpoints get the same URL, they also need to instantiate the rules the same way. What is the IP address of the app? What is the IP address of the device, etc. We also discussed the content of the SCHC header when SCHC is encoded to compress the ULP, the IP ULP or some IP next header. And so we said that we need something like an IPv6 extension header, even if that extension header will never really show on the wire because we will compress it. It has to match the IPv6 architecture. So it has in the uncompressed form to be like any IPv6 extension header. So it has a next header length. It needs a checksum because the goal is to protect the SCHC header and then everything behind it, like the ULP header, say UDP. The idea being that the SCHC header checksum protecting the UDP will allow to compress the checksum in the UDP or in TCP because UDP and TCP are protected by SCHC itself. And then whatever information is needed, like the session ID. And I see that which could be expressed in the same form as a UDP port, so we use the same value. Laurent, you have a question? Do you want to speak?
Yes, do you hear me?
Yeah.
Yes. Okay. Just a clarification about the next header. For you, it's like in IPv6. It means that it's a layer 4 protocol, or it can be also an extension.
It could be an extension header. I mean, the thing that comes after. I mean, the idea is to represent the SCHC header in the header chain, and then it compresses what is after, and then the rules will tell you how to uncompress everything that is after. So it could be a URP, it could be a destination option header, it could be something.
And this, what you propose here, the format, is it's a protocol or it's an extension?
It's this format would be for an extension header, an IPv6 extension header that goes in the IPv6 header chain. So it can be placed before the URP, or it can be placed in the middle of the header chain. It has to be after the hop by hop. But after that, it's just a new extension header.
Because I think it's a point we have to discuss, because extension is not so popular right now at IETF.
Yes, it's true. But we never see it on the wire, right? We will need to ask for the header type and the protocol type, if you like. But it's not on the wire. You don't see a difference because it's compressed. And what makes it?
But if we put it as an extension header, when we have to also to say that we compress the whole extension header around.
Yes, we compress the extension header. Yeah. But I mean, it doesn't make a difference on the wire if it's an extension header or URP.
No,
I mean, it's just
yeah.
next header SCHC and then binary.
My goal is more to say that I have two questions here, and for myself. One is, do we need really to go to extension because it can be difficult to push? And the second thing is, for example, this can apply also over, I know, let's say 82.11, and in that case, we don't have IPv6. We have a layer 2.
So this is a particular format that contains the data that we discussed. When it is IPv6, when it is, for instance, PPPoE, or when it is an Ether type, and so we compress even layer 3. I mean, the header has to be different. So yeah, go. So we have a long list of people, but yes, this header is when it is IPv6.
Eric has something to say. He wrote it also in the chat.
Yeah, and that's basically to the same vein as Laurent. So speaking here as an individual contributor, but I'm mostly sure that the IETF has decided that it will never define new extension headers. So that will be a no-go.
Yeah, because we don't want them on the wire, Eric, right?
But but you need to define
this is
it,
more
Pascal.
like to respect the architecture, but you will never see it on the wire. It's more an architectural concept.
But you will need to get one via the IANA or whatever. It will be in the host visible. So that will be really challenging to get.
Yes, it will. And the same thing. Yes, it will be challenging.
If you get finished, Pascal, you can either go, my advice, to go to a destination option, which is then okay, or you simply ask for an IP protocol.
We had that discussion. If you ask for an IP protocol, then you are ULP encapsulating another ULP, right?
Correct.
Like
and you will be at the end of the existing of any existing extension header chain, if there is any.
Say that again, please.
So if you are defining it a new IP protocol, so like any ULP, it will be at the end of any existing extension header. So they cannot be compressed. Of course, that's a minor issue, maybe, or a big issue. But honestly, if you really want to use it as an extension header that could be into the extension header chain, you will face the big challenges at the IETF.
I understand. So we are looking at the architecture we want to build. And now I understand that that's going to be a fight. There were fights as well to compress checksums in UDP and stuff, and we made them in the past. And I remember the draft by Suraj saying that it's harmful and we don't want any new header, and the reason was mostly to pass firewalls. And actually, there are two formats, Eric. So you were not there maybe at the last interim, but you can do this also inside UDP in case we want to pass firewall. So that there is a format where we work over IP, and then there's a format where we work over UDP. And there's also a format where we work directly over SCHC Etherpad. And in each case, we have to ask the same questions. I mean, do we identify the endpoints? Do we identify the endpoint role? And then what do we need to put in that header? So this is kind of a construct when we operate in the IPv6 header chain, meaning that we want a real IP packet, for instance, a UDP packet, to be compressed by SCHC. So the writer, maybe I still have one picture of that. Let me just move a little bit. Yeah. So imagine a packet which has the normal ULP. So say ULP equal UDP. So you have the blue piece, next header equal UDP, then you have the black piece, UDP header, and then you have the purple piece, which is the UDP payload. And now we want to say, hey, we are in the stack and we have this blue, then black, then purple thing. And we want to compress it with SCHC. And like I said, we need to signal the SCHC information, like the SCHC session and everything. This is when we need to insert something before the ULP to say how we are going to compress the ULP. So before we speak any compression, that means that we have a SCHC header for which the next header is UDP, and we cannot insert it. So it's not on the fly on the packet that comes in and goes out. It's as we build the packet. But really, we want to build it such that there is this SCHC header, which is the next header for IPv6, and for which UDP is the next header. You see, architecturally speaking, that's the proper construct. And from there, effectively, we know that asking for a new IPv6 header will be difficult. But if we explain that it's never to go on the wire in that form, and if we want to pass firewalls, then there is the alternate format, and it's also described, and we are writing the text in the architecture. In that case, the port in UDP indicates SCHC, and that really means that we'll get kind of the same information as before, but expressed in this first green block here. Now, I'm talking about the information that we want. I mean, do we have the endpoints? Do we have the session? Do we have the roles, etc.? But we need that information and the session ID to know how to compress what comes next. But you see, basically, this red thing, why, when we don't have UDP, why we want it this way? It's just because it is inserted before the ULP, but the ULP is still the ULP. The ULP is not SCHC. The ULP is UDP or whatever else. But once we have the SCHC information and then the ULP as it was originally, then you can compress everything starting from the red thing. Do I make sense?
Yes, and actually, for my understanding, Pascal, so this only applies for this case where SCHC goes over IP. So the legacy stays the same. So we don't have this next header and so on. Or how do we distinguish that if this kind of also is applied for legacy? How do we distinguish which version are we using in a way?
I don't follow you. What legacy you're talking about? I mean,
legacy is the whole compression of up to IPv6.
I can maybe I can answer
Right.
if you want, Pascal.
Please go.
Yeah, I think right now we have it. It means that right now we have the red part that exists on all the SCHC frame, but is empty because we don't put any. It's not defined in the context. If you define the SCHC header in the context, then you have two solutions. Your SCHC header contains only no sent, not sent, which means that everything in the context will never go on the wire, on the radio. And if you have, for example, you want to to send 1 or 2 bits, so it will be also saying in the context, and then you send either rule ID or not. If you have only one rule, you don't need a rule ID. If you have several rules, then you need a rule ID, and then you define the same way your compression as for the rest of SCHC.
I got a
Does
bit
that make
confused.
sense?
Sorry. So
Yeah.
basically, what you mean is that the rule ID will tell you which. So, and in addition to this, you will need the rule ID first. Is what you were trying to say, or
Yes or no? So you have three cases. First case, you don't have a SCHC header that is defined in your rule. So it's what we have done right now, and there is no change. Or you define for your rule a SCHC header that, for example, is everything is not sent. So explicitly, on the receiver, he will decompress a SCHC header, and he will get, for example, the next header or thing like this. So it can be, for these two cases, it's totally transparent.
In the air, right? In the air, you don't see
There.
any of this. You don't see a single bit. But the difference between your case one, which is what we do for LoRa, in LoRa, everything is implicit. There's only one session. The endpoints are the device and the application, and they know that they are the device and the application. So everything is implicit. There is just no need of a header, even in completely compressed form. So that's your case one. Your case two is, yes, there is a need for the header, but if there can be only one possible header, so only session 0, I would say. And you don't need a checksum, so that would be, for instance, if you compress above .11, as you said earlier, then effectively you can say the whole SCHC header is well known, it's a constant, so I can write it in my rule, and if I write it in my rule and there's only one possibility, I don't even need a rule ID, that's your case, your second case. It is there, but it's fully compressed without having any rule, because there is just a single way of writing it. And then there could be different ways of writing it, like you have multiple sessions, in which case you will need rules, effectively. But this format, here I have a binary, it's just to say, hey, when we integrate it in the IPv6 header chain, because we want to compress what is after it in the header chain and the ULP, so it's kind of inserted between IP and ULP, then it should, to be architecturally correct, look like this before we do any compression. And after that, effectively, we do compression. And so it's just, after the IPv6 header, it's just a binary blob. Now, it could be that there is a firewall, and the firewall doesn't like at all that there is a binary blob right after the blue, right after IPv6, in which case we need UDP before the blob to just pass the firewall. So we basically will, for SCHC over IPv6, we'll have to describe the two formats. The formats where it's basically what goes on the wire is blue and binary blob. And when you have IPv6 plus the UDP and then the binary blob. But the binary blob itself as a semantic, it is effectively consistent with the IPv6 architecture as an header in the header chain. It's just for IPv6. We have to discuss what we do when it's Ethernet or .11 after the Ether type. We have to discuss how we do over UDP for stuff. But the format that was given here was really for IPv6 for this red thing. Laurent, you wanted to say something? Laurent?
I cut my mic. Yes, to answer to the question from Carsten on the list, maybe, so if, for example, we compress UDP, then we need a checksum somewhere, because that's what IETF mandate. And one solution, for example, is to use maybe to use the CRC instead of a checksum that can be more compact if we need compactness.
And the whole is shown here. It says basically first we have the SCHC header, and the SCHC header has a checksum or a CRC, and it will have to be inlined. That one cannot be compressed because it protects the red, the black, and the purple. It protects everything. So if you just rely on the UDP, say the ULP here is UDP, if you just rely on the UDP checksum, it will protect the black and the purple, but it would not protect the red. We want to make sure that the red is protected as well, meaning that the checksum that we have must protect everything starting from red. If that's the case, there is not really a point of transporting the UDP checksum in the compressed form, because we know it's already protected by the red checksum. So that's why the expression on the wire would look like what you see on the second half of this picture. First, a SCHC compressed SCHC header, but as part of the compression, you might still have to inline the session if you have more than one session, and you still have to inline the checksum because the checksum itself, you need it, cannot be compressed. You need at least one checksum somewhere to validate the whole thing. But once you've done that, you could claim that you can elide the ULP checksum because the red checksum already protects. See?
I agree.
So in the
that was my first point, but Alex maybe wants to say something.
Yeah, yes, thank you, Laurent. I find this really interesting discussion, and of course, I think that it will be really good to focus on okay. So I a couple of questions here, and one of the things is right here we are talking about IP and IPv6, and then of course is the encapsulation in Ethernet. So I think that we should try to have the same type of header for the SCHC session, for independently of if we are in IP or sitting on top of Ethernet, right?
Yes, I mean, completely agree. That's why we listed the information that we need in the SCHC session in general, and we said if we instantiate it for v6, that's a possible format. But the abstract information that we want is this, and it's independent on whether you do it at layer 2, 3, or 4.
So that was my second point, Pascal. So in the next slide or previous, I don't know, you show the format, the format for SCHC header. This one, I think it's confusing because here you define something with a bit order, etc., that will never exist. So maybe
it will not exist on the wire.
On the wire. So yes, that's why. So when you put 0 to 31, it means that it's something that exists on the wire. What I will suggest.
Oh, it could exist in memory at some point.
Yes, I also read it as something that goes over the wire. Yes.
So, for example, in what we have done in 8724 and 8824 is that we have an abstract representation of IPv6, UDP, and CoAP. And maybe we have to keep at this level for defining the header. So we can have, for example, SCHC.NH, SCHC.HL, etc., that will say all the fields that we may find in a SCHC header. And then we say, okay, you can put them into a SCHC rule, and it will give you this compression rule.
But Laurent, I'm just thinking about, not talking about the architecture document, because I don't expect this drawing to be in the architecture. I mean, I've been writing the text, I've not published it, but I've been writing the text that goes with it in the architecture document. And effectively, this picture does not show. I don't need it. It's just like you say, we need the abstract information. But at some point in the code, you will have to apply the rule to compress something and then to decompress it and go back to something for which the checksum works, because you will have to validate the checksum. And so we need at some point in memory to be very clear on what is exactly in the packet, because we'll do a checksum for it. And so that even if it never flies like this, because of the value of the checksum, we need the format. Do I make sense?
Yeah. Yes,
So
alas.
probably just something. If we can just maybe get the discussion about the checksum, you know, on a second, like on a separate topic, because like, okay, there is the checksum question, right? What needs to be protected where and what level? But for me, it's like, before we actually go to that, okay, let's say, okay, there's the checksum, but before we go to that, there are a couple of other questions here. And the first question is, so is it next header or is it a header extension? So from what I hear,
It is the same thing, right?
yeah, it's
next header is the next extension header. So do we need
no,
to
I mean,
define
yes,
an
next header, but I mean, it's next header or sorry, yes, or a protocol or a layer 4 protocol. Yes. So, and I, from the way I see it, I don't see how what more. So if you define a new protocol level, new layer 4 protocol or a new extension header, but well, they're probably both going to get filtered when you run through the internet, right? Some
Yes, that's
firewall
why we
going
have
to,
the other format,
yes.
which is when you do
Yes.
everything over UDP. Yeah.
Yes, so I don't see what's the point of having an extension header instead of having a layer 4 protocol ID. It doesn't bring you a value to have the extension header.
We'll have both. If you're doing something like inside a factory, and you don't have a firewall, you want to be efficient, and you have some, like, you want to have the smallest frame possible because you're putting it in a time slot and whatever else, and you want to schedule your time slots very quickly because, like, you want a 1 millisecond response time on your Wi-Fi or something, then you don't want to waste bytes, and there's no point using UDP. So that's when it's handy to do SCHC over IP. Now, if you have bandwidth or if you have firewall, then you do SCHC over IP with UDP in the middle. It's really a use case.
Yeah, but I mean, it's why don't we have just a new protocol number and then we have SCHC over IP and it's the same picture, just not a new header extension.
In terms, at some point, you want to reconstruct blue plus black plus purple, so you can pass it to the stack. And so,
yes,
having
so
a
you get,
SCHC header, yeah. So the SCHC header is really a header that virtually you insert and you remove, but your packets remain the same. Now, if it's a protocol, then you would need to have a protocol within a protocol. I mean, architecturally speaking, I just don't understand what that is. Or it's a tunnel protocol.
It's a protocol between the two SCHC compressor decompressors. This is. I mean, it's
weird, right? I mean,
probably it's not it's not the
SCHC
place.
becomes a like UDP. It becomes like a tunnel thing, or SCHC becomes like a GRE variation over UDP. I mean, what is it? But in that case, it's the picture that we have here. SCHC over.
Well, I mean, so I perfectly agree about the UDP, and we'll need the UDP part, and so okay.
If you have UDP, then the SCHC header is no more an next header, right? It's whatever we want it to be.
Good. Yes, and from all the other cases, we can handle, well, there is SCHC between some compressor.
So this is the case we're talking about. Agreed?
Yeah,
we talk only about this one, no UDP. Yeah.
Yes, no UDP, exactly. But for me, it's not next header. It's just a new IP, and there's actually a document like IP protocol number by
If you have an IP protocol, I know we are writing this document, but if it's only an IP protocol number, how do you say inside there is UDP, there is UDP, or there is TCP? I mean, how do you change the real ULP?
But what do you care about this in the middle, outside of the SCHC? Like, if you are already behind the SCHC decompressor, then you already have the decompressed thing, so you know that it's like IP with UDP and all that. But between the two SCHC compressor decompressors, well, you either have the rule to decompress the thing and you can see that it's UDP inside, or you don't have the rules, and in that case, well, you know, it's just a blob.
Yeah, but it's like you say, it's garbage. I mean, you don't structure what you do. That's why I'm talking about architecture here. I mean, I want to have a structure that explains what is what, and that's why a next header, which basically think that the normal packet has the blue, the black, and the purple. And that's what you want to restore in the end. Once SCHC is done, you in the stack, you want to see blue, black, and purple.
Yes,
And
I mean, so that works with an IP protocol number. That works with this. And just for me, I don't see what next header adds to that, right? And especially in the case like if it was, well, we can add the next header with no problem, then sure, let's work with that. But as Eric said, at the IETF,
well, just because it's going to be hard, you want to be the garbage, to do the garbage thing as opposed to the clean thing. Don't we just try, and then after we can always say that SCHC is the ULP, and then we handle everything that's behind that's as a big blob. But
okay, so
it's
Carsten,
not as clean as managing, as knowing exactly what we do.
Okay, so what Carsten says that he considers that we will need both.
Yeah,
okay,
that's what I believe. Just like
okay,
Carsten, I believe we need both.
Okay,
and
so then we should have, for me, a SCHC header definition
but
that
it's
is
the same value if you look at it.
the
It's
same,
just that
yes.
whether we call it just a protocol type or because the same in a table in the end. So we need to request the value saying it can be an next header. And if effectively 6man or somebody does not want it, then we'll have to fall back to what you're saying. But for me, it's a garbage format. If we no, it's just a big bag and you put your stuff in it. But I don't like it. If I can have the clean way, I'd rather have the clean way.
So what Carsten says is that we need both. So we will need both the IP protocol plus the extension header.
The next,
So,
yeah, but like I said, it's the same table, same value. So it's just a matter of qualifying it.
okay,
Saying,
so
hey,
Carsten
it can
wants
only be used as a protocol, or it can also be used as an extender. I see Carsten is trading now.
Okay, so Carsten also joined, and Laurent. So Laurent, do you want to say something or?
I don't remember what I wanted to say. So.
Okay, so Carsten, then you take the word and
yeah. So
yeah.
This kind of seems familiar to me. We had these discussions like 20 years ago, we in the end came up with a need to actually have an IP protocol number for ROC. Because there were protocols where you plug in IP protocol numbers. I, for instance, IKE. I don't think we can really avoid getting a protocol number. The other thing is, if you want to do SCHC over Ethernet, then you need something that goes between the Ethernet header and the SCHC information. And you also need to do that. That's a separate thing. And there are a few little obstacles here that you may want to read my draft from 19 years ago and check whether these obstacles still exist or actually maybe have become worse than they were 19 years ago. So
can you put the draft in the minutes, please, Carsten, because I will read it.
It's in the chat. I also can put it into the minutes.
Carsten?
Yes.
Okay, have you finished?
Yeah, so I don't want to make all the points that are in those documents. It's much easier to just read the documents and see what problems we had to solve at the time. So I don't want to waste your time on this.
Okay, no, but that's great. Okay, so we'll have to. I'll read it at least for the next time, and I agree here, right? And I think it goes with the same logic that we'll need some kind of universal way to have this header defined, and maybe not make it too complex at the same time. And there was just one thing. So, Karsten, back to you.
Yes.
Or you are finished? No, because your hand is still raised. So that's.
Oh, okay. I'm sorry. I forgot to take that away.
Yeah, I did the same thing a minute ago. So okay, so that's perfect. Thanks. And Pascal, one other thing about the. I mean, I think that you have already. So I understood the thing about the format. Can you go back to the table? Yes, to this one. So no, the next one. Yes. So here there is one thing that I think that the session ID, of course, in some cases you can say like it's the port or something like this, but we should leave it. You know, I think it could be good to have several lengths for the session ID. And the reason for that is that I think that in some cases it could be useful to have some kind of universally unique session IDs. Such as like some universal identifier that can tell you, hey, this context, let's say, or this kind of a session is based on something that is universally known. So the way we do it with LoRaWAN, for example, in LoRaWAN, as you say, you have this well-known. You know, like we know that we're on LoRaWAN, so we are following this well-known context. But in the same way, we can figure out a scheme where we know that there is some kind of universal ID, and whenever that ID is used, well, this particular context, which can in the same way as the LoRaWAN. So and maybe it can be long. So probably we'll need a couple of lengths for the session ID so that we're able to decompress things. Yes, Laurent.
Yeah, so that's a good question you raised, and I remember now what I wanted to say. That if we do something and say we need a format, we need a size, then we open things where it will be difficult to define a format. If we say, for example, we have a session ID and we take only the 3 bits, and we have a LSB and we send only a 3-bit on the wire, then maybe it will be, we don't care about the length and it will be adapted to the configuration. And to answer to Pascal about the checksum, if we do the checksum on the full header of either, of course we have this problem. But if we push the checksum on the compressed header, then here the format will be given by the rule, and we don't have any more this problem. So for me, it's better than not to fix too much things. And when we have a header, we define some size, and maybe it will not apply.
That would be a difficult discussion if you don't do the checksum on the non-compressed stuff, because you have to prove that you restore UDP correctly in the non-compressed version. So you could say, hey, I do the checksum on the compressed chick header, but the not compressed ULP, I don't know. I mean, that's details, but it can be a bit difficult. Now, back to the reason why it's 2 bytes in this proposal. It's just a proposal. The reason why it's 2 bytes, it's because the goal was to make it compatible with this format. When you have this format, the source port is the session ID, and the destination port is well known for SCHC. Just like we said we need an Ether type, and we said we need a next header / IP protocol, we also need a UDP port because of this format here. So we need a 3. For each layer, we need something that says SCHC. And if we use UDP encapsulation, then the destination port going from the device to the app, destination port would be SCHC, and source port would be basically the indication of the session, which allows to elide it in the red thing. So when the red thing in the green block is really the SCHC header being compressed. And if really it's 2 bytes, then we can say, hey, the session is the one that you find in UDP. If it's longer, then the rest of the session must be quote unquote well known. So if you say the session is bigger, Alex, you say, for instance, it's 4 bytes, I don't know. Then we could say, hey, when for all the sessions that go over UDP, the first 2 bytes are well known or something, and only the last 2 bytes go in the UDP port. I mean, there could be ways of doing it. Now, I see also Laurent's proposal, which is, more generic. You just don't say what length it is. You just place the delta, and people will know the rest. And then there's a checksum prime. It will be harder to digest. I mean, I see that it can work, Laurent. It's just harder to digest.
So actually, that's a good question. I think that we need to figure out some kind of minimal header that's universal for all. Let's say 1 byte. Let's see, we have a 1 byte header that tells us, okay, well, if the first bit is 1, then blah blah blah, and then we know, okay, well, it's clever, the thing that you're saying with the UDP session. I mean, that I like that very much, right? But maybe you don't, but maybe in some cases you want to do something else, and then the SCHC header needs to be bigger or maybe smaller at some point. But let's say that if take that place here. This report. Yes, but in any case, like to define some kind of really header, that things that go on the wire, right? And because it's and then from the wire we go to the virtual bits that we construct and reconstruct, right? So that we have like something that can sit on top of Ethernet, that can sit on top of IPv6 as an X header, or as a header extension, or an IPv6 as a IP protocol.
It would be really nice, Alex. And I mean, we've been discussing that, the IETF, and since it's very hard. And then I asked the question last week, actually, or 2 weeks ago, last time interim. It's very, very hard to have the same SCHC header regardless of the layers, because sometimes you can say, oh, I know the role because of this. Sometimes you can say, I know the endpoints because of this, and sometimes you have to pass them. And then the checksum, effectively, if you're layer 3 or 4, you need the check. Well, if you're layer 3, you need the checksum. If you're after UDP, you don't need the checksum. So the format, once you decompress, the format that you get would be different depending on the layers. So the rules will be different. I guess we need a set of rules for every layer. The abstract information that you want to get at the end is always the same, right? It's this information here. But the way we would virtually express it before compression, quote unquote, depends really if you're over Ethernet, over PPP, because in PPP you have the PPP session, which you can use, so you don't need to pass it in the rules, etc., etc. So I guess formats and the rules would be different. I don't see that it's easy or even so desirable to try to create the same thing at every layer. It would have been great, but if it's more effort than benefit.
Yeah, well, I mean, PPP is a particular case, right? I mean, PPP is point-to-point, and others are not point-to-point. So yeah, in point-to-point, it's like you can say, I set up, like you can detach pretty neatly the setup of the connection, of the point-to-point connection, and the rest. And okay, I see, but of course I'll need to contribute text about this, right? I mean, here I'm just like I just wanted to. I mean, of course it's easy to talk, right? I need to contribute text about this, but I just wanted to see what are people thinking about.
What I'm doing right now is I'm trying to write what was on the slide last week and during the IETF 117 in the document, in the architecture, and as a starting point. I'm not saying that's going to be the truth, right? But at least that's where we were so far. So I've been writing 90% of it already in my in my version of the document. Now we can, once I've written that, now we can decide to edit it and change it. But at least I'd like to push a consistent version of the text, which is pretty much those slides. And then if we don't agree, if we come back and diverge from that, then let's change the document. But yeah, I'd like to push it cleanly, if you don't mind, with just this.
Well, of course,
yes,
I mean,
I've not.
if you've written the text, of course, please publish it.
I'm editing. I was editing today, effectively, and I had started before. That's why I was asking you guys about affiliation and stuff, because I wanted to update that as well.
Yes, we'll need to do that. But
by the way, we all the authors of the CHC architecture are changing their affiliation. So that's a lot. Okay, so yes, please think. I see your point. I mean, Anna raised it. Please think exactly how you think it could be done and how complex it would be to have the same header, same rules, same everything at every layer. But for me, apart from the abstract information that you get out of those headers, plus the other headers, because for instance, the endpoints, if you have IP, you can expect that the two endpoints are well known if you do it over IP. Now, if you do it at the application layer, it could be that the endpoints are application endpoints, not the source destination IP, and you need more information like a service access point in the CHC header to know exactly, oh, it's between this guy and this guy, so that's this session, same session number, but two different application endpoints. So that's why I'm saying, I mean, the binary format that you obtain once you apply the rules and decompress will be different everywhere. Because sometimes you need more or less information, sometimes you're bound to format, sometimes you're not. But basically, we are advancing with Bob Moscovich this document where we ask for IP protocol on an Ether type. And what I want to do with the next generation is to say, hey, let's ask for, and if we lose the fight, we won't get it, but let's ask for an extension header. And let's also ask for UDP port because of those slides. We want CHC over UDP. We want a UDP port that says, hey, it's inside this CHC. Laurent?
Yes, about session boot and what you put about rule location and authentication. So I think it's very, very important to have this to identify the rules. But once we have set up a session at any level, so we can have management. And in the RFC 9363 about young data model, we say that only, in fact, we can write it now, and only endpoints can manipulate their own rules, and that's all. You cannot have access to other rules, and only those you are dealing with. So now that we have a layer of CHC, and we have also seed ID, so session ID, sorry, we need really to think about the way we will do management at all these layers. And so, for example, if we use a core conf, how we can be sure that the rule include a way to do core conf or compress it, of course, and all that stuff. And for me, it's not clear how we do that. So from outside, we need a URN, but where we are inside, then we have to see how we can manipulate things without identification, because if we put identification, it can be a way to attack another device. So we have to study that.
I agree. I mean, do you want that to be the main topic for the next interim? We have an interim 4 coming 2 weeks.
I don't know. Maybe Anna wanted to present something.
Anyway, if you don't mind, I will write down what I represented here and presented last time and at IETF. And if we don't agree on that finally and you want to come back, then we'll have more interims to find the final thing. But I thought that was almost agreed, so that I had started writing. So I just would like to finish that writing and show it and publish with it, because we by the way, the one thing about the architecture is we passed the 6-month date, so we need to publish something. Document has expired. Yes, Laurent, you're still raised?
Oh, it's my turn to forget to press the button.
Laurent. Okay, we are reaching the end of this discussion. So do we have any other business we want to discuss? I'm hearing none, so I guess you're saving 5 minutes of your life. And I can go back to finish the edition that I started about the SCHC header. So I understand the opposition, and I have the same about using an extender, but that's the clean way of showing things in memory. So if it doesn't pass, we'll do the dirty way, I guess, like Alex said. And with this, thanks so much all for attending this meeting, and we meet again in 2 weeks. Bye-bye.
Thanks, Pascal.
Bye-bye.